Hello and welcome back, everyone, to the 61st Annual Seminar on Glass presented by the Corning Museum of Glass. For those of you just joining us, my name is Catherine Larson, and I'm the museum's curator of ancient glass, and also the organizer for this year's seminar and the curator of the special exhibition Dig Deeper: Discovering an Ancient Glass Workshop, from which this year's seminar is taking its theme. We'll get started with our keynote momentarily, but in the meantime, I just wanted to remind everyone that you can place questions for our speaker in the Q&A feature, and you may also use the chat feature to interact with other participants. Our technical support team is available to assist. You can reach them through chat in the lobby or by email at avuser@cmog.org. And we will have a bit of time at the end for questions from the audience. I'd also just like to add a reminder that the museum will not tolerate hate speech of any kind, and we ask to please keep the comment section in this year's seminar respectful and supportive. So without further ado, I'm so delighted this morning to introduce our first keynote speaker, Dr. Yael Goren-Rosen. Dr. Goren-Rosen is head of the glass department of the Israel Antiquities Authority, a position she has held for over 30 years. She's taught courses on glass history at the Bezalel Academy of Art and Design, the University of Haifa, and the British School of Athens. She has published more than 250 reports on glass vessels from excavations in Israel, dating from the Hellenistic period through the Middle Ages. I can't even read everything that Yael writes. I don't know how she finds time to actually write it all. I can't keep up. She also serves as an editorial advisor for the Journal of Glass Studies, and was a really key intellectual contributor to the Dig Deeper exhibition. Dr. Goren-Rosen's keynote lecture, titled Glass from the Furnace, Glass from the Depths, The Glass Industry in Israel, an Overview, will place the Jalame excavations and discoveries into the broad context and history of glass workshops in the region. Thank you for joining us, Yael.
Hi, thank you, Kate. Good morning or good afternoon. Thank you all for joining us today from all over the world. Many thanks to Carol White and Kate Larson for inviting me to participate in the seminar. I'm happy to be here with you. Please accept my apologies in advance for any errors in my English. If there are any questions at the end, I will be happy to answer them. Some of you have prior knowledge of the topic, while others may be unfamiliar. I have included additional information in the presentation to ensure everyone is on the same page. Next slide, please. This paper summarizes more than 30 years of study and recent discoveries. The primary focus of this presentation is the process of creating raw glass, known as primary production. I will also mention the secondary production, namely the manufacturing of vessels and objects. These industries are separate, yet interconnected, and you will quickly understand where and how. Just to note that these industries have different types of installations. Their size and scale of production and their debris are different. It is also worth noting at the beginning that over hundreds of years, these installations deteriorate and left very poor remains for us to study. The raw glass furnaces produce between 10 to 20 tons of glass in one production process. After the glass is ready, the glass makers demolish the furnaces to take out the glass for sale to the secondary workshop, where a few dozen kilograms of raw material and cullet is recycled glass, are melted to produce the glass object. With these pictures and basic information, we can start our journey. The paper was arranged chronologically, while some general topics discussed alongside the findings. We will trace the evolution of the industry from the beginning of the first millennium CE onwards. However, this approach does not align with the history of discoveries and their significance in enhancing our understanding of the manufacturing process. Next slide. Like anywhere else, glass production in Israel has been studied through 5 primary sources: archaeological artifacts, written records, anthropological research, experimental studies, and chemical analysis. In this lecture, I will focus on archaeological finds and written sources, while the remaining 3 sources will be discussed in upcoming lectures. Next slide. When discussing primary glass production, we must consider 4 main topics: location, distribution, organization, and trade. The location of industrial area depends on several factors, including the availability of raw materials, fuel sources, environmental conditions such as wind, temperature, and rainfall, transportation and trade routes, and potential markets. When discussing mass production, it is crucial to consider the distribution of workshops, production capacity, technological knowledge, artisan skill, and production organization. All of these factors are closely related. Next slide. In 1990s, there was increased attention given to the glass production process. 2 important conferences in 1998, one in Ohio on behalf of the American Ceramic Society, and the other in Lyon, organized by Marie-Dominique Nena, focused on this subject. The proceedings of both conferences were summarized and paved the way for further research in this field. Before the year 2000, our knowledge about glass production sites was limited. The map on the left, published in La Rue de Verre, shows just 3 primary production sites: Apollonia, Bet Eliezer, and Bet Sheʻarim, and less than 24 secondary production sites. The map displayed on the right show only the primary production sites that were discovered until 2015 and are considered the most reliable, namely only the sites where remains of furnaces were found in situ or large quantities of broken furnaces were identified. Yavne, which is marked by a blue circle on the bottom left, is the latest primary and secondary mass production site that has been discovered and can now be included in the map. We will visit most of these sites immediately. This map, we produced for exhibition in 2016, summarizes the distribution of primary and secondary glass production sites and the raw glass chunks found in the sea, near the coast. Firstly, the distribution of glass production sites throughout the land of Israel is wide, from the north to the south and from the west to the east. Secondly, you see that in several sites we found both primary and secondary production, as well as raw glass chunks in the sea. These sites are marked with a white oval frame and include Akko, Caesarea, and Apollonia. The red oval frame marks all the sites where the remains of both primary and secondary stages took place. Digging deeper reveals that the industrial areas were located in urban centers and in rural sites. The number of workshops dedicated to secondary production has significantly increased, going from around 24 to around 100. These workshops have been active for a period spanning 1,500 years, from the late Hellenistic era up to the Mameluke period. In certain locations, such as Jerusalem and Akko, remnants from multiple workshops from various periods have been discovered. Please. Once the introduction is completed, we may start our journey. We start at Akko Bay on the northern coast, where the river Naaman, known in antiquities as the Belus River, flows into the Mediterranean Sea. During the early Roman period, it was already known that the Belus River sent was of superior quality and ideal for making glass. Strabo, in his book, Geography, wrote about the transfer of sand from Ptolemais, Akko, to Tyre and Sidon for glass production, as Ptolemais, Akko, had stopped glass making. Next. Pliny the Elder recounts a story of Phoenician traders who transported natron blocks on their ship and stopped on the sandy coast near the Belus River. The sailors used natron blocks to support their cooking vessels over the fire. After firing the sand, the liquid glass appeared. Although it sounds like a fairy tale, it is based on fact. It is known that one of the products transported by merchants in ships over the Mediterranean was natron, which was used for various purposes, including the production of glass. The melting of natron with the wonderful sand that accumulated in the Akko Bay creates high-quality glass. Next. Josephus Flavius once mentioned the exquisite sand found in the Belus River, indicating a specific area close to the Memnon monument, which was likely situated in or around a cemetery. Two miracles occurred in this place. First, ships carried away pure sand, which was then replenished by fresh sand blown in by the wind. Second, the sand in this location turned into glassy sand. From the written sources to reality, recent excavations to the north of the Naaman stream, known in antiquity as the Belus, have revealed several cemeteries along with remnants of raw glass manufacturing. Next. It is uncertain where exactly the furnaces were located, but it is assumed that they were situated near the Belus River or on the outskirts of the city near the sea. Based on salvage excavations, we can now suggest that glass production began in the early Roman era in the city, but the exact location of the furnaces remain unknown. The cluster of orange triangles indicate the cemetery region situated north of the Tel, marked with a white circle, where the north stream of the Belus River might have flowed. Today, the river flows south of the Tel. Remains of glass production activities were collected in all the salvage excavations north and west of the Tel. Some of them related to early Roman period, while others to later production. Another example is indicated by the green circle, a salvage excavation on a main street in the city center, close to the beach, revealed remains of a Crusader bathhouse, and below them were fields with glass production debris. Number one is a fragment from the floor of the glass furnace, while the rest are bricks with remains of glass from the furnace walls. To summarize the production of raw glass in the late Hellenistic and early Roman periods, there are two sources of information: written accounts and production debris that lacked furnaces. Additionally, the chemical composition of early Roman glass suggests that there may be undiscovered production centers in the vicinity. During the Roman period up to the 4th century and possibly later, there were workshops producing glass products known under the trademarks Judean glass and Alexandrian glass, as mentioned in the Diocletian Price Edict issued in 301 CE. These products and their prices were well known, carved in stones, literally, all over the Roman Empire. However, it is unclear where the Roman furnaces from the 2nd and 3rd centuries for the production of the Judean glass were located. As for the Alexandrian glass mentioned in the Price Edict, contemporary huge furnaces were discovered by Marie-Dominique Nena in Wadi Natron, Egypt. The furnaces excavated in Egypt represent a powerful Egyptian production center which deserves a special lecture by the excavator. Meanwhile, I suggest you Search the YouTube for the movie called The Oasis of Glass, produced by Marie Dominique Nena, to see the Alexandrian trademark. And back to the theory, and back to our story, please. Jalame was the focus of the Dig Deeper exhibition and the reason for this seminar. You have learned about it already from Carol White and Kate Larson. Therefore, I can skip the introduction of the site and the excavations conducted in the 1960s. During my doctoral research, I studied the Jalame report by Gladys Davidson-Weinberg and her colleagues, which includes findings from a secondary glass workshop. I noticed that some of the debris presented in the final report may have originated from raw glass production rather than secondary production, and that both stages probably exist in the same area. However, with the knowledge of the 1980s, they could have identified only the secondary stage. Additionally, some of the Jalame debris was stored in the Israel Museum storerooms, and I checked it. A few large boxes contain various chunks of debris, including large fragments of furnace floors and walls, chunks of partly vitrified material, and several types of bricks. Based on previous experience from several excavations, I identified the debris and suggested that the so-called red room, you heard about it earlier, in the report was used for a raw glass furnace rather than secondary production. However, the secondary furnace was not far away, and its debris was scattered in the area. You are looking at a reconstruction of a secondary glass workshop. If we examine the operation process, we can expect to find remains of the furnace, piles of glass ready for melting, along with other common glass blowing leftovers and many vessels and broken vessels. But the Jalame furnace's debris found in the boxes was slightly different. Here you see two examples of remains found during excavation of a secondary workshop. On the left, you can see piles of raw glass chunks and vessels, and on the right, leftover materials from glass blowing and glass vessels. Have it in mind before we go back to the primary stage. If we look at the plan and reconstruction published by Weinberg and her team from one hand, and the debris found in the area, and just take out the glass blower on the upper right corner, these are remains of the primary production furnace on the upper Jalame Hill, excavated in the late 60s by Gladys Davidson and her team. Just before submitting my thesis with a chapter on reconsidering Jalame, I received a call from the field inspector Abed El-Salam Said, who works in the Israel Antiquities Authority in the region of Jalame. Abed observed construction on the new East Railway between Haifa and Bet She'an. In the Jalame Hill trench, he discovered an ash layer beneath a floor. Glass chunks and debris were also collected in the trench. Abed invited me to take a look at the finds. Looking at the three indicative chunks on the left and the section of the trench, it was clear that we expected to expose the remains of the furnaces. Weeks later, we began excavating together. We had a limited budget for 1 week and 8 professional workers. And during this time, we uncovered parts of the floors of 2 melting chambers and a corridor. After requesting a budget for another week of excavations, we had to wait 6 months before continuing the excavations during the following winter. Due to the time constraints and unstable weather, we began our winter excavation season on a sunny day, as shown in the top left photo. However, just 2 days later, heavy rain poured down on us. Despite the adverse conditions, we worked diligently to dig up as much as we could, knowing that the area would be demolished soon after we finished. During our exploration, we came across the remains of 4 glass furnaces. There were 2 pairs of furnaces with a corridor between them. Unfortunately, the furnaces on the left were only partly preserved due to the ongoing construction work. However, the pair on the right was better preserved. When we looked towards the northeast to the southwest, we could see Mount Carmel on the upper part and the Jalame hill on the left. In this southwest to northeast view, 2 furnaces stand on the left and right, with a clear section below them. They were built directly on the soil. Here you see a well-built melting chamber made of filled stones as its outline and a row of fired bricks with a plaster layer between the stones and the bricks. A layer of plaster was used to create the foundation for the melting chamber. Only small fragments of the firing chamber were found, while the melting chamber had a size of around 3.80 on 1.80 meters, almost 4 on 2. Focus on the details of the furnaces, including the division between the firing and melting chambers and the details of the corner made of stones and fire bricks. On the bottom right, you see a chunk of raw glass from the furnace floor that shows good quality with only 2 centimeters of debris below it, consisting of partly vitrified material. Here is a preliminary version of the site reconstruction. In summary, the new Jalame raw glass furnaces were constructed using a variety of bricks, including fired lime-based bricks and red mud bricks that were fired during the process. At the end of the melting chamber, there is a large structure that appears to have been upstone. In summary, the new Jalame raw glass furnace were constructed using a variety of bricks, including fired lime-based bricks and red mud bricks that were fired during the process. At the end of the melting chamber, there is a large structure that appears to have been constructed to support a chimney. Between the furnace, there is either a corridor or a working area. The glass produced was of high quality and was removed as blocks with no remnants left at the site. The Jalame glass furnaces were probably built during the late Roman, early Byzantine period, namely in the 4th century, contemporary with the secondary production discovered by Weinberg and her team. In regards to the location, the site is situated on the southern edge of Akko Bay, making it easy to transport high-quality sand. The shoreline was much closer in the past, allowing ships carrying natron to anchor there and transfer the product to the Jalame workshop. They could utilize the Kishon River, located north of the site, as a means of transportation. This route could have also been used to export the raw glass to distant ships for trade. Fuel was gathered from Mount Carmel and the surrounding vicinity. The valley experienced the strongest winds at this particular location. The discovery of primary and secondary states taking place in a single site is quite thrilling. In the past, it was commonly believed that these 2 industries were separate and primary production was limited to only a few locations. The excavation in Israel over the last 30 years revealed the coexistence of both stages alongside pottery production and agricultural industries such as wine and oil presses. The debris from the oil and wine presses was probably used as fuel in the glass furnaces firing chambers. We were fortunate to have received the scholarly support provided by our colleagues. A special thanks goes to Caroline Jackson, Ian Friston, and Matt Phelps for the spontaneous visit during the final days of the excavation. The study of the site is currently ongoing with analytical research on the building materials and the glass. Several sites contain remains of raw glass production dating to the late Roman and early Byzantine period, specifically from the 4th to early 5th centuries. While no furnaces were discovered in their original locations, the quantities and characteristic features of the debris indicate that they were used for primary production. I'll mention them briefly. Horvat Bitsa. The location of the site is on the western foothills of the Samarian Mountains. The excavations uncovered the remains of a building, pit, and the industrial area, including debris from a glass furnace, raw glass chunks, and fragments of glazed brick. Horvat Bitsa is a rural industrial area where both primary and secondary production took place, similar to Jalame. One area yielded remains of raw glass production, while the other revealed blowing glass overs, number 13 and 14, for example. The secondary glass production found at the site was determined to have originated from late Roman to early Byzantine periods, specifically to the 4th and early 5th centuries, as well as the Byzantine and late Byzantine periods up to the early Islamic period, which spans from the 6th and 7th centuries to the mid-8th century. During surveys in the Sharon region, evidence of glass production was found at multiple sites located between the Samaria foothills and the coast. Roll and Ayalon, the surveyors theorized that the growth of new settlements with limited agricultural land spurred alternative industries such as pottery and glassmaking. It is believed that the producers of ancient times used oak trees as fuel during the production process. The region where the production took place had excellent crossroads connections and coastal sand or sandstone. It seems that the only imported element was natron, which was most likely obtained from Wadi Natron in Egypt. Many years after the surveys, salvage excavations were conducted in two of these sites, Horbat Miska and Horbat Chanot, due to the construction of new roads. Next, please. At the site of Horbat Miska, debris was discovered in garbage pit. From this, we can infer that the furnaces were located somewhere nearby. The debris was too heavy to be transported and could not be recycled or reused. Next. In the upper left corner, there are fragments of furnaces floors, while the rest is made up of various debris chunks. Next. In addition to primary production, a limited repertoire of homogeneous glass vessels dated to the 4th or early 5th century were found along with remains of the glass industry likely contemporary to them. Next is Horbat Chanot, located east of Mishke. 12 big boxes of glass production debris were collected, while large heavy chunks were left at the site. The remains include mud bricks. One part of the surface is glazed and the inside is mud. With a negative of dried straw, sometimes there are small stones that are visible in the section, as you can see in the middle. Next. Debris from the furnaces, floors, and wall. The photos on the left show 4 sides of the same chunk. You can see that each one presents a different texture. Only very few fragments of glass vessels and windows were found. In one area, remains of glass vessel manufacture were uncovered, among them 2 moils, glass buttons, and a few drops. The location of the site is ideal for glass making, and it was probably part of the same economic development in this region mentioned earlier. We continue our journey to the south and to the most recent and exciting excavations marked in the red circle at the bottom left. This is Yavne, a mega project, the largest excavations ongoing in the country for the last 5 years. The excavations revealed many different installations and cemeteries covering 7,000 years on the slopes of the ancient Tell and its surroundings. To understand the scale, in the photo you can see wheelbarrows parked in one of the excavations areas. On the left, you see the city of Yavne and part of the excavated areas. On the right, the location of area M and L, where the glass workshop is located. A plan of the area. The glass workshop is marked in the blue circle, and on the left is a small wine press. The area in the center is the Roman cemetery, in which hundreds of candlestick-type bottles were found in one spot. You see only some of them. To the right, a pottery workshop, one of many unearthed at Yavne from different periods. The glass workshop was part of an industrial area where agriculture industries like wine presses were located aside from pottery production, both built near a Roman cemetery. Looking from above, the glass workshop is in the center, the wine press on the left, and the cemetery on the right, part of the cemetery on the right. The remains of 2 rectangular primary production furnaces and 5 circular secondary furnaces were found in a glass house, dated to the 4th or early 5th century, contemporary with Jalame. This is the first site where both stages were practiced in the same building. We're still studying all the findings from this excavation as the project is ongoing in other areas. The 2 primary furnaces were about 4 meters long and 2 meters wide. The floor of the melting chamber was found almost clean, except for small pieces of glass. The left furnace was cut by a trench, and the right one was cut by a later wall, which was built from the recycling of furnace walls. These furnaces were built above earlier structures. The 2 narrow chambers on the bottom might have been the firing chambers of the raw glass furnaces or part of a secondary furnace. Here we have a close-up of one of the secondary furnaces where a flat stone marver, the working table of the glass blower, was found in situ. Look at the marver in front of the reconstructed furnace and the one we found at the site. You can easily imagine the ancient the glass maker at work. Piles of blowing debris were found near the secondary furnaces. Here you see just a few taken during the dig. Yavne deserves a special lecture, but we must go on to the Byzantine and later periods. The location of primary production sites can be divided geographically into places near the sea or at a distance from the sea, on the hills or slopes. The choice of location also takes into account the environmental conditions and potential transportation, or in different words, accessibility. Moreover, location also includes identification, an urban environment, a rural site, or even an isolated industrial area. Issues of location are also mentioned in the written sources. For example, urban laws of the Byzantine period assigned to Julianus of Ashkelon protected the inhabitants of the settlements from polluted industries, namely the iron and glass makers. Such laws were probably the result of the growing and flourishing glass industries, which in some places were established in the cities. Just imagine that Yavne, the distance between Yavne and Ashkelon is about 20 kilometers, less than 20 kilometers. So you can imagine where the sources for the ideas of Julianus of Ashkelon. The glass furnaces at Apollonia, for example, were located outside the city wall at the fringe of the city, in the industrial area on the north part of the city and to the south of the city. You will hear a lot more about Apollonia from Ruti Jackson-Tal, so this slide is just a promo to Ruti's lecture. At Caesarea, the glass furnace is located on top of the sand dunes facing west, inside the Byzantine city wall, but on the fringe of the city, over the ruins of a Roman amphitheater. See the blue star. The furnace floor was found upside down, and therefore the glass layers are invisible in the picture. But please imagine that below the slab in the yellow frame, a layer of glass from the melting tank floor is visible. All the area around it was covered with fragments of debris. Caesarea was a metropolis during the Roman and Byzantine period and was still a big city during the early Islamic period. The blue point at the bottom of the map shows the natural anchorage of that period, where raw glass chunks were found in the sea, probably from shipwrecks that were identified there. Remains from a secondary furnace were discovered a few years ago at Caesarea. Like Apollonia, both production stages are at the same place, as well as raw glass chunks from the shipwreck. We go north of Caesarea to Dor, which flourished in the Hellenistic and early Roman, but was just a small fisherman's village afterwards. During the Byzantine period, Dor was a pilgrimage center with a big church and probably hosting facilities, but not a big city. After the church went out of use, glass production took place on its ruins at a close distance to the sea. Underwater excavation of shipwrecks in the bay clearly show the importance of this small anchorage. And some raw glass chunks were also among the finds discovered there. The best example of a production site in a rural environment is Bet Eliezer. It is the biggest ancient glass production site ever found, situated approximately 10 kilometers from the sea. The site is located between the Samarian foothills and the coast. The site of Bet Eliezer was discovered in 1992 and was a turning point in the understanding of the mass production of raw glass. For the raw materials, the area is covered today with red soil, but ancient dunes are located nearby, and Kurkar, the conglomerate sandstone, are also available nearby. Natron was probably imported from Egypt, which means depending on a routine supply of a major ingredient from a distance, requiring a secure trade route and stabilized administration. For the fuel, to the east of the area are the low hills of Samaria, which were covered with wood up to the Ottoman period. In addition to the timber, bushes and weeds were probably collected for fuel. Other sources of fuel that were probably used were debris from olive press and dung. The furnaces were built directly on the ground, similar in size and axis, built from local mud bricks of similar size. The reusing of bricks from previous furnaces was visible, indicating the existence of previous installations in this area. This is something that we must consider when calculating the production capacity of a site. Each furnace contains two firing chambers and a melting chamber. Most of the remains at the site were the floors of the melting chambers. The firing chambers were poorly preserved. After the end of the process, the furnaces were demolished to enable the harvest of the raw glass chunks. They were carefully cleaned from the raw glass produced in the tanks, and almost all the finds in the site were debris from the furnaces with small raw glass chunks. Most of the furnaces were used only once. The only pile of raw glass found was probably stored in a sack and left behind, but generally the site was clean of medium and big raw glass chunks. The capacity of one furnace at Bet Eliezer was estimated by comparison of its size with Bet Sheʻarim and its preserved height to about 10 tons. We uncovered the remains of 17 furnaces at Bet Eliezer, and it seems that there were more furnaces at the site that produced slabs like this one, the one you see in the picture. We don't have time to discuss the Bet Sheʻarim site, which is exceptionally by all means. It is also later in date. It's an unsuccessful process which left us with the only example that survived of the shape of a raw glass slab produced in a melting tank, as it was left in situ due to its failure. The composition of the glass is also important as it presents the transition from natural-based glass to plant ash glass. The slab was studied by Bob Reel from the Corning Museum. Based on the 17 furnaces found at Bet Eliezer, we assume that raw glass production was seasonal. During the winter, this area was covered by a swamp, and when it partly dried, the workers probably made the bricks and let them dry in the sun. During the summer, they built the installations and collected the raw ingredients and fuel. At the end of the summer and the beginning of the autumn, they started the production with the help of the west and southwest winds. This timing was perfect after the end of the watermelon season and the harvest of the grapes, but contemporary with the olive harvest and the production of olive oil, which left a large amount of debris that could have been used as fuel. I would like to stress this point of the connection between the agricultural industries and glass production sites. One of the results of my study is that glass production was mainly located in rural industrial areas alongside wine presses, oil presses, and various industrial installations like pottery and lime kilns. The latter, pottery and lime kilns, share the need for a large amount of fuel and the creation of heat and pollution. Therefore, they were mainly located far from the inhabited area. This process represents a highly developed organization and technology, and skillful glassmakers with groups of workers. This successful process ended with 100 tons of raw glass from one production site, far beyond the local demand. Imagine that in a certain period, several workshops produced similar quantities. This points to specialized production aimed for export. Such mass exports need governmental support to be able to protect and control the roads, the ports, the trade routes, and the merchants, as well as to collect the taxes from this flourishing industry. I'm stressing this point to put glass production in its place as one of the most important economic branches in ancient Israel, at least during the first millennium of our era. To be more specific, after the three most important agricultural products, namely wine, olive oil, and wheat, raw glass was the major industrial product exported from ancient Palestine. This is probably the most important conclusion of my study. To summarize the issue of the distribution of raw glass industries, it seems that most of the sites were located in the Sharon between the coast and the Samarian Hills, the majority in the north of the Yarkon River and up to Duro. Evidence for a few more sites enlarges this distribution map further south and north. Two more centers that were identified are the Carmel and its coast and the low hills of the Western Galilee east of Akko, like Kfar Yassif and Achiud, on the north part of the map. As mentioned earlier, the capacity of raw glass production in these sites was far beyond the local demand and was made for export. The evidence for trading raw glass are raw glass chunks found in shipwrecks in the Mediterranean and raw glass chunks found in a wide distribution, showing similar and even identical compositions to those of glass found at production sites like Apollonia or Bet Eliezer. The raw glass was traded by sea. It could have been used as ballast. It is well known and widely agreed that it was the cheapest way. Therefore, we can imagine that a ship taking a cargo of wine or olive oil would also take a ton or more of raw glass chunks. The study of glass composition in many sites all around the Mediterranean show this phenomenon. The study of raw glass chunks found near the Israeli coast also confirmed this trade. Thank you.
Thank you so much, Yael. That was fantastic. What a great way to put Jalame in context of all the other amazing work that's happening. And yeah, I'm seeing a lot of applause and hearts from our audience.
Thank you.
Yeah. There's one question so far, and I encourage everyone else to kind of ponder your questions. Janessa asks, sorry if I missed this, but how was the glass retrieved from the furnace once it was done firing? Presumably the primary furnaces.
They have to wait after the glass is completely finished the process of making and melted, and after 2 weeks or a month, when it's done, they close the firing chambers and let it cool very quickly. When the glass cools very quickly, it cracks and breaks. And then they break the ceiling or the wall and take out all the raw glass chunks to sell it overseas or in the local market, or most probably overseas.
So that superstructure was disassembled, and that's one
Yes.
of the, to get the glass out. And that's one of the reasons when we excavate, all you have is that footprint of the tank that's left behind.
Exactly. Only in very few places we see reusing of the same place. But again, they had to destroy the first furnace and to build. Now, if you have, if the industry is inside the city, you want to save place, so you will reuse the old furnaces or the place of the old furnaces. But when you do all the process in a rural site and land is not an issue, you don't have to build the furnaces again and again on the same place. That's the thing we saw in Bet Eliezer. We have 17 furnaces that used only once, and only one furnace used twice.
Another question, do you know where the raw glass was shipped for secondary production?
Yes, I think the answer might come from the chemical, from the analytical. It goes all over Europe and beyond. We found Levantine 1 and Levantine 2 compositions, which covered Apollonia, Jalame, Apollonia, Bet Eliezer, all over the ancient world. It was widely used exactly as the trademark Judean glass versus the Alexandrian glass. And maybe Ian will tell us more.
Yes, we think most of the glass that travels through the Roman Empire and Byzantium would have been made in this area. There's some being made in Egypt and a few other places as well, but almost all the glass is coming from this region. Yeah. Why do you think there were 2 firing chambers instead of just one for each primary furnace?
Because if you have a problem in one, or you stuck the fuel in one, for the management, you need at least, you must have ongoing firing all the time. So, and if you see the 2 furnaces in Bet Eliezer, they both face to the west and to catch the wind. So we may assume that they work together, or only one was working while they stock the fuel in the second. So to maintain 24/7 firing chamber, it's better to have 2 firing chambers instead of 1.
That makes sense. This is a hard question to answer, but do we have any sense of, were these continuously operated? Were they seasonal? What's the sort of frequency or cadence of the firings of these furnaces, the primary furnaces?
If we look at Bet Eliezer, for example, we may assume it was seasonal. And today, I'm counting more on the olive press debris. So I believe they work the furnaces in the autumn, immediately after the finishing of the producing the olive oil, because this is the season. The autumn is the season with the best winds, the best western and southwestern winds, and the furnaces were based on these winds. The circulation, the wind, the air circulation in the furnace was based on winds, not on bellows.
Right.
So it must be seasoning, and also it's after all the agricultural seasons, and so they have time, fuel, and
yeah. Ian, sorry, go ahead. Ian also adds, you need to clear the ash from the firing chambers. So having 2 firing chambers would allow you to clear out one over these long periods. Yeah.
Thank you, Ian.
What about variation in color? What was the most abundant color distinction?
Oh, great question. The majority, of course, is bluish green, greenish blue. You have seen it through for example, it's Bet Eliezer. All the furnaces were bluish green, greenish blue. Only one has the brown color on the edges. So we assume that they color the glass in the secondary, mainly in the secondary furnaces. In the secondary production.
Thank you. Got a couple others. This is a question I've actually gotten a lot too, and I'm not sure what the answer is. Can you tell how the ingredients were arranged in the chamber? Do we know anything about how they were mixed prior to firing?
We believe, if we get back to the first slide, in the presentation, we believe that they made piles near the furnace. They made piles and they mixed everything outside. They measure it by a basket. They couldn't measure exactly by kilograms, but yes, look at this one. And mix it outside the furnace and put it inside. After they mix it in the right ratio between the raw ingredients.
And then it's placed inside the furnace.
Yeah. And then the firing chamber. And then they probably have spy holes in the upper part to see the color of the fire, the color of the glass inside, see if and also maybe to mix it during the process in a way.
I see. A clarifying question. So is colorless glass also secondary, part of the secondary process of strongly colored glass, also secondary, or is colorless glass?
Yeah. No, this is something that we see in Egypt, that the furnaces produce something near colorless. So, but if they produced colorless glass in Israel, in ancient Palestine, it was probably done in a secondary stage, not in the first stage. In the primary, they produced the bluish green from the natural sand with natron, and only later they color it in secondary stage, secondary production stage.
Marie Doe has a question. Can you redevelop on Akko in the Hellenistic chronology? I'm not sure I understand the question fully, but kind of about the Hellenistic chronology of Akko, potentially.
We have Hellenistic glass vessels from Akko, but we don't have enough information about Hellenistic production in Akko. We have the earliest information about production in Akko comes from early Roman, not from Hellenistic period yet. We don't know what future.
Another question on color. The blue-green comes from the addition of natron.
I think Ian and Dri will answer all the questions about chemical compositions and colors.
Yeah, generally the blue-green's coming from the iron, but if you're interested, that's in with the sand. But if you're interested in these, yeah, I think, let me check my time. We are 1:35 Eastern, so in a little bit over an hour, all things chemical will be resolved. Okay, last question. You touched on this, but can you please talk more about the kind of fuel that would have been used?
Okay, to use the wood from trees or bushes, or it's something that's all over. But here, when we have mass production of olive oil and wine, both seeds and debris from the process, from the pressing process, is great fuel, because the debris from olive oil is rich with oil, and we know that in the Arab villages they use this debris up to the 19th century. So this way. We know also that in Yavne, for example, we don't have wine presses, but we don't have olive wine presses, and the debris of wine presses is also full of oil. And so it can be used as well. Another option is dung. We know that dung was also a fuel used until the 19th century. In the Samaria hills, even up to the early 20th century. So we have different types of fuel, but I believe today that the close distance between the olive presses and the wine presses to the glass is the key to understand this economic and ecologic, let's say, very modern way of recycling and saving energy.
Yeah. Thank you. This was really wonderful. Thank you again. And we will now take about a 45-minute break for lunch or dinner, wherever you are. And I hope to see all of you back again in about 45 minutes at 1 o'clock Eastern time here. Thank you, Yael, again, for really a wonderful, informative talk. Learned so much. So thanks, everyone. See you soon.
Bye.